I was just wondering about the energy. What, according to you, energy really is? We mainly define energy into two forms: the static form of energy and dynamic form of energy. What you meant by static form? That the type of energy which you can store. Common examples are kinetic energy or maybe potential energy. Apart from that, we also have the dynamic form of energy. These energies you cannot store. You can only observe these types of energy when it is flowing from one system to another system. The very basic example of the dynamic form of energy are heat and work. Heat is a form of energy that will only flow due to the virtue of temperature difference. One can only observe the heat when it is flowing from one system to another system. One more thing that we should keep in our mind, that heat will always flow from high temperature objects to lower temperature objects, and vice versa of this is also true. Means if is there any kind of temperature difference, the heat will have to flow. For that, you can understand in this way. Suppose I have a beaker in which we have a very hot water. Now, if I place my hand in this hot water, you will see that heat will flow from this high temperature objects to the lower temperature. That is my hand. Now, I take my hand back. Now, my hand is bit hot as it was earlier. If I place the same hand again on the cube of ice, what will happen? The temperature of my hand will again decrease. How? Because heat is flowing again from high temperature objects, that is my hand, to the ice, which is at lower temperature objects. Thus, from all these experiments, you should always keep in your mind that heat has to flow if there is temperature difference, and the direction is always from high temperature objects to the lower temperature ones. Now, we'll understand more about the heat transfer and the increase in the temperature. We know that if we increase the temperature of any substance, its volume, its area, or maybe its length will increase. Thus, we will conclude that if the temperature is increased, then any substance will also increase in all the three dimensions. You should consider these things in your mind while designing any engineering structure. I hope every one of you have been traveled in train before. Have you heard this sound and wondered why this type of sound came? Actually, if you notice the railway track, you will see that in between the two consecutive rails, there is a little gap. Why is it so? Actually, this gap is given intentionally. Because if the engineers will not provide the sufficient gap, then due to temperature increase, the railway tracks will increase in the length. And as I was telling you that if the sufficient gap is not provided, then the thermal stresses will generate and the railway track will buckle, which is not a good thing. Now, let us try to generate simple mathematical relation for all the three-dimensional objects. Let's start with the one-dimensional body. For that, I simply take a rod. You will see, let's say that this rod has an initial length L. Now, if I increase the temperature of this rod by the providing heat, let's say I increase the temperature by delta T. Now, I can say that the change in length due to this change in temperature can be written as delta L, which is the change in length, equals to L alpha delta T. Here, L is the original length, alpha is nothing but the coefficient of linear expansion, delta T is nothing but change in temperature. Now, as we did with one-dimensional body, we can also generate a relation for the two-dimensional body. For two-dimensional body, I considered a simple plate with a hole in it. Now, let's say this plate has an area A. If I increase the temperature, let's say by delta T, its area will also increase. Again, writing the same way, we can say the change in area delta A is equals to beta A delta T. Here, beta is nothing but the coefficient of areal expansion. A is the initial area and delta T is the change in temperature. Similarly, we can also generate a relation for a volumetric body. Suppose I have a cube. Now, if I again increase the temperature of this cube by, let's say, same temperature difference delta T, what is the change in the volume? Again, we'll write it as delta V, which is the change in volume, is nothing but V gamma delta T. Here V is the initial volume, gamma is the coefficient of volumetric expansion, and again delta T is the little change in the temperature. For isotropic substances which have the uniform properties throughout the space, we can define that gamma is equals to 3 times alpha. Gamma is nothing but the coefficient of volumetric expansion, and alpha is nothing but the coefficient of linear expansion. Apart from all these, liquids will also expand if you increase their temperature. In fact, you can also treat phase change as an expansion process, as the distance between the molecules will also increase. In the case of liquids, you can simply put the relation of the volumetric expansion. There is one catch. Apart from all the liquids, water is slightly different. This is the reason why icebergs float on the water. Actually, in case of water, if we try to increase the temperature from 0 to 4 degree, the volume of the water first decrease, then it will increase. Like you can see in this graph. Here, from 0 degrees Celsius to the 4 degrees Celsius. When the temperature is increasing, the volume is decreasing. And after that, then volume will try to increase. This is known as anomalous feature of water. I hope you got all the concepts discussed in today's session. For next session, keep learning and keep exploring.